Hi, this is Srikanth, Assistant Professor of Computer Science Engineering, Data Science Department. In this session, I am going to cover what is transportation model, how we are going to solve the transportation problem by using this. So, after completing this particular topic, we can easily apply the optimization technique to find initial basic feasible solutions which move towards the optimality in transportation problems, including unbalanced and maximization cases. Here, the above problem has got the following properties. Any transportation problem has got the following properties. It has an objective function which is going to have objective function like in the linear programming, and it has structural constraints, and it has a non-negativity constraint, and the relationship between the variables and the constraints are linear. And we know very well these are the properties of a linear programming problem. Hence, the transportation model is also a linear programming problem, but it is a special type of linear programming problem. And once we say that the problem has got the characteristics of linear programming model, and then we can solve it by simplex method. Hence, we can solve the transportation problem by using the simplex method. We can solve the transportation problem by using simplex method because it is like a linear programming model. As we see in the above given transportation model, the structural constraints are of mixed type. Okay, here whatever the constraints which we have taken are mixed type. In this, some of the constraints are less than or equals to type, and some of the constraints are greater than or equals to type. So these are the considerations we need to be taken care while we are solving the problem. When we start the transportation problem by simplex method, it takes more time and laborious. So many calculations, so many repetitions, so many iterations, so many steps we need to do by using the simplex method. Hence, we use transportation algorithm or transportation method to solve the problem. So, because of more time consuming process, we are going to solve the problem with transportation algorithm or transportation method in order to solve the problem. Before we discuss the transportation algorithm, let us see how a general model for transportation problem appears. Okay, before going to the transportation algorithm or a model, we need to see how the general model will be there for transportation problem. The general problem will have m rows and n columns, that is m by n matrix. And here is the transportation model will be having minimize z, which is equals to summation of j is equals to 1 to n and summation of I is equals to 1 to m Cij xj, such that where I is equals to 1 to m and j is equals to 1 to n. And in the same way, constraints are summation of I is equals to 1 to m Aij xij, which is less than or equals to bi, where I is equals to 1 to m and j is equals to 1 to n. And in the same way, summation of Aij xij, which is greater than or equals to dj, where I is equals to 1 to m and j is equals to 1 to n. Now, the similarities between simplex method and transportation problem are both have objective function, both transportation problem as well as simplex method both have the objective function, And the next one is both have linear objective function, and the whatever the objective function which is having, that is of linear objective function in both simplex method as well as in the uh, transportation method. Both have non-negativity constraints. So in both method, in simplex method as well as in the transportation method, both are having non-negativity constraints. That means all the variables are greater than or equals to 0. And the next one is both can be solved by simplex method. So here both have non-negativity constraints. Here both can be solved by simplex method, but in transportation model it is laborious. And the next one is a linear programming problem can be reduced to a transportation problem if all the AIJs or coefficients of the structural variables in the constraints are restricted to the values 0 and or 1. There exists homogeneity of units among the constraints. And the differences between these two are transportation model is basically a minimization model, whereas general linear programming model may be of maximization type or minimization type. The resources for which the structural constraints are built up is homogeneous in transportation model, whereas in general linear programming model they are different. And the transportation problem is solved by transportation algorithm, whereas the general linear programming problem is solved by simplex method. So whenever we go with transportation problem, we have to solve by using transportation algorithm. Whenever we are going with linear programming problem, we can easily solve by using the simplex method. The values of structural coefficients are not restricted, xij are not restricted to any value in general linear programming model, whereas it is restricted to values either 0 or 1 in transportation problem. So the values are not restricted in the linear programming model, whereas in the transportation problem these are restricted to either 0 or 1. The steps used in getting a solution to a transportation problem is given below. The initial basic feasible solution, which is balancing the given problem. The first one is balancing the given problem. In the transportation algorithm, we are having several steps. Let us discuss those steps in order to solve the transportation problem. So the first one is we need to find initial basic feasible solution. So first we need to in this step 1 is first we need to balance the given problem, and balancing means check whether the sum of availability constraints must be equals to the sum of requirement constraints, that is summation of bi is equals to summation of dj. Once they are equal, go to step 2. If not, by opening a dummy row or dummy column, balance the problem. Okay, if once they are equal, we can directly go to the step 2. If not, if they are not equal, we have to open a dummy row or a dummy column in order to balance the problem. The cost coefficients of dummy cells are 0. Here, the dummy cells cost coefficients will be given as 0. If summation of bi is greater than the column whose requirement constraint is equal to the cells or zeros. In case if summation of dj is greater than availability constraint, which will be equals to the summation of bi minus summation of dj, and the coefficients of the cells are zeros. In case if summation of dj is greater than summation of bi, then open a dummy row whose availability constraint will be equals to summation of dj minus summation of bi, and the cost coefficients of the cells are zeros. Once the balancing over, then we are going to the step 2, second step. Remember, while solving the general linear programming problem, to convert an inequality into an equation, we are going to add a slack variable, that is for maximization problem. Whereas in transportation problem, the dummy row or dummy column exactly similar to the slack variable. As like in the simplex method, how we have added slack variable in the linear programming model, in the same way here in the transportation model, we are going to add a dummy row or a dummy column. And step 2, we are going to find a basic feasible solution by using the step 2, and in this the basic feasible solution can be obtained by 3 methods. They are northwest corner method, least cost cell method, Vogel's approximation method. After getting the basic feasible solution, give optimality test to check whether the solution is optimal or not. After getting the basic feasible solution, we have to go with the optimality test in order to check whether the solution is optimal or not. And there are 2 methods of giving optimality test. One is stepping stone method and another one is modified distribution method, generally known as Moody method. And the properties of basic feasible solution, that is, the allocation made must satisfy rim requirements, that is, it must satisfy availability constraints and requirement constraints. So whenever we are going with the transportation problem, we are going to have 2 different types of constraints, whether there is a availability of that particular constraint and the next one is requirement constraints. So whenever we are going to allocate, we must satisfy the rim requirements, such as we need to be satisfy availability constraints as well as requirement constraints. It should satisfy non-negativity constraint. This is must and should for linear programming as well as transportation model. And the next one is the total number of allocations must be equals to m plus n minus 1, where m is the number of rows and n is the number of columns. Consider a value of m which is equals to 4 and n is equals to 3, that is 4 by 3 matrix. This will have 4 constraints of less than or equals to type and 3 constraints of greater than or equals to type. Today it will have 4 plus 3, that is m plus n inequalities. Total 7 inequalities we are going to have. If we consider as equations for solution purpose, we will have 7 equations. In case if we use simplex method to solve the problem, only 6 rather than seen structural constraints need to be specified. And in view of that fact that the sum of the original capacities availability equals to the destination requirements. So whatever the availability constraints must satisfy the requirement constraint, that is summation of bi should be equals to summation of dj. Any solution satisfying 6 of the 7 constraints will automatically satisfy the last constraint. And in general, therefore, if there are m rows and n columns in a given transportation problem, we can state the problem completely with m plus n minus 1 equations. This means that one of the rows of the simplex table represents a redundant constraint and hence can be deleted. And this also means a feasible solution of a transportation problem has m plus n minus 1 positive components. And here, if b summation is equals to summation of dj, it is always possible to get a basic feasible solution by northwest corner method and least cost cell method, or by Vogel's approximation method, that is also known as VAM. These are the references I have taken for this session. That is operations research and introduction to operations research and operation research by S.D. Sharma. And these are the web references I have considered. And in this session, I have discussed what are the steps involved in the transportation model and how it is different from linear programming model, and also what is the algorithm for transportation model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.